Good afternoon, Year 10, and welcome back. Today we are going to be looking at proving that vectors lie on a straight line. So by now we have covered the basics. We have covered adding and subtracting vectors. Well, we've covered what a vector actually means and how it's represented with the xy components. Then adding and subtracting vectors, multiplying vectors by a scalar, showing that two vectors are parallel. The next thing we need to do is being able to prove that vectors lie on a straight line. And this actually just uses the parallel vectors stuff that we learnt last time. That was a terrible introduction, Year 10. I do apologise. So we learnt last time that if two vectors are parallel, then they are multiples of each other. So for example, we might have the vector a plus 2b, and we might have the vector 3a plus 6b. Because we can take 3 out of this, that means that this vector and this vector are parallel because they are both multiples of a plus 2b, or this one is a multiple of this one. If we represented those vectors, let's say we had point A and point B, and let's say that was a plus 2b, and then we had vector 3a plus 6b over here, which joins P and Q. Because that green pen lid is just over there now. Did that last time. So for these two, because this one is 3 times this vector, we can say that AB and PQ are parallel, and PQ equals 3AB. So that's just a recap of parallel. Now, if we had this setup of vectors, we've got A to B is A plus 2B, and we've got B to C is 2A plus 4B. Now there's two things going on here. The first one is that we can factorise out 2. And now we can see that BC must be parallel to AB because it is a multiple of A plus 2B. So AB and BC are parallel. However, AB and BC also share a point. They share point B. If two lines are parallel and they share a point, they must be travelling in completely the same direction. So A to C must be a straight line, because we've travelled from A to B, and then in exactly the same direction we've travelled from B to C. So altogether this must make a straight line. So AC is a straight line since AB and BC share point B. And that is the principle we are going to use to prove that 3 points lie on a straight line. So A to B and B to C are parallel, and they both have point B, so they must be in a straight line. If I had an extra vector over here, P, Q, and that was 3a plus 6b. We can say it's parallel, but we can't say it lies on a straight line because it doesn't have any points in common. This one's over here. We can't say P and Q lie on this line because we have no evidence that they do. They don't share any points. But these two vectors share point B. And so that's how we know they lie on a straight line.